Hello and welcome everyone. My name is Peter Robinson, and today we've got David Hyland-Wood, who is going to present about AI and Web3 and how they intersect. Before we dive into your slides, David, could you please introduce yourself and, maybe very, very briefly introduce the topic to warm everyone up?
Sure. Thank you, Peter. I'm David Hyland-Wood. I'm head of R&D for ConsenSys, and in my copious spare time, I'm also a senior AI researcher at ConsenSys. My background is primarily in knowledge representation, and I'll mention how that fits into the broader AI field later in the talk.
Sounds great. So please fire away with your slides.
I will gladly do so. Let's see. Now, if I present that slideshow, are you seeing just the slide?
Yes.
Oh, excellent. I love it when technology works. That's lovely. So the talk today is how AI can assist Web3 adoption. For anyone who's over 40, I apologize for ConsenSys's new color scheme. It can be a little hard on the eyes, but I've done my best to mitigate it, except for the green on white, which drives me absolutely batty. This presentation was the result of some work that Dr. Sundar Johnson and I have been doing together at ConsenSys. We've been working on an internal position paper for the application of various AI technologies within ConsenSys, and we have an academic research paper in progress on the topic as well. So this is a summary of the last couple of months, maybe the last 3.5 months of learning for me on this various topics of the intersection between AI techniques and Web3. So first, I'm going to talk about what we mean by AI because it is such an overused term and often confusingly so. Then I'm going to talk about the intersection about Web3 and AI, what we mean by that, what our practical options are for such an integration, and what they're intended to accomplish in a Web3 context. Very briefly, I'll talk about what's been done to date, and then what I think is probably coming. And then at the very end, of course, we'll sell you some T-shirts on the Ethereum Engineering Group merch store. So what do we mean by AI? If there's anything that I've learned about AI to date, it's that most people can't spell it. They use the term very inconsistently. They confuse the broader AI term with whatever particular form of AI is hot in the headlines at the moment. And of course, in 2024, that means language models. But of course, there's more to it. So there's more to it than this slide suggests. But these are kind of the main categories of AI as they've developed over the last 50 years, at least the ones that are still around. So my particular piece of this knowledge representation doesn't even show up on this slide because knowledge representation is generally used to organize and refine data as input to some of these other systems, be they ML or natural language processing expert systems, vision systems, etc. So large language models, of course, came out of the natural language processing branch, specifically around question answering, chatbots, machine translation, and now we see a lot of progress in text generation as well. So that the language people, the NLP people, have made some terrific strides in the last 4 years, and of course now it's very much a mainstream activity. There's still a lot of machine learning, statistical based approaches or integration with deep learning networks, and they even might dominate by deployed systems today. We still have a lot of expert systems in retail and warehousing, for example. We have a lot of vision systems and robotics. We have speech systems, and of course, all these things are getting um, uh, integrated together. So I'll talk a little bit about the orchestration, but for the moment, I'll focus on LLMs since they're the new hotness. This is the general large language model architecture. This would be the architecture of ChatGPT, for example, and it's really quite similar to the architecture of most large language models. It's complicated. When you see things like feed forward, the blue boxes there, just those boxes are quite large recurrent neural networks. An RRN or a recurrent neural network is a deep learning model that's trained to process a sequential data input, stream of data into a specific sequential data output, a stream out. And so these things are great for these kind of NLP tasks. But a lot of what makes this a tractable amount of computation, because RNNs are so heavily cross-connected. They're deep learning networks where nodes connect to a lot of other nodes, and there's a lot of feedback within them. And so these things are hard to train. They're big, and that takes a lot of compute to train. It takes a lot of time and money to train these things. But at runtime, you want them to be reasonably fast. The critical insight that came out of this is this paper that's noted in the lower right, attention is all you need. This is based on research that was done at Google. The first research was really done around 2020. And the big insight was that substantial progress was made in text generation and language processing when you use various techniques to associate words in the input with other words in the input. That's what they mean by attention. When a word is processed, attention is paid to its context. So you might say, the cat was attacked by the dog, right? Which is the same thing in English as saying that the dog attacked the cat. And so you've got words in there that don't really mean much, like an article in English. And you've got words that are really critical. What's the subject of the sentence? What's the predicate? What's the object of the sentence? And so the encoding of attention, the relative relationships of words to each other in a sentence turned out to be not just an important aspect of this process, but the critical thing that allowed large language models to jump from doing a partially decent job on machine translation to really jumping forward in the step function that we saw over the last few years. Now, let's break this down just a little bit. So I said how complicated the networks were, the feed-forward networks. Some of these things are actually quite straightforward to compute at runtime, which makes them tractable to run in real time. And that's because these yellowish boxes, the masked multi-head attention, the way that's actually accomplished are large matrices of the vectors that represent the words that are flowing into the input. Each word is, of course, turned into a number because it's processed into a computer. Vectors of these words, quite large vectors of these words, are created. And you can then do some fancy tricks with matrix multiplication, which is a very cheap operation to mask the input so that the matrix multiplication gives you the attention vectors. And that allows you, the combination of those two things allow you to give a very rich relationship of denoised input into those neural networks. It's the runtime efficiency of those matrix operations that makes the whole thing tractable to run in real time, like a chatbot. So let's break this thing down a bit. The bit on the left is the encoder. The bit on the left, on the right, is called the decoder. So the whole thing as a group is an encoder decoder. The encoder's output feeds into the decoder, and the decoder actually eats its own tail. It takes the output of its own computation and it feeds it back into its input, and it goes in a loop as long as you want it to go, which is how you get text generation out. Now, it doesn't go forever because you'd run into the halting problem, right? And so that's why LLMs normally give you a bounded set of output, 500 words, 1,000 words, whatever they're set to. And of course, that's configurable. So on the encoder side, what you're doing is you're taking these input texts, you're creating these vectors of numerical representations of all the words, and you're running it through this attention mechanism and then into this feed forward recurrent neural net. The decoder side partially reverses that process with changes. So let's talk about what those three variations are good for. You've got an encoder only, the bit on the left, that's the top one here in this image, where encoders, if you just limit your system to that part of the architecture, what you're getting is what they call an auto encoder. You've got the teacher something the student, and then you get a target of teaches. You're trying to train the thing that when it sees that pattern, you're going to fill in the result. That's your automatically encoding when you see that pattern input. A decoder side, the decoder side is known as an autoregressive system. And that's a text generator, right? It'll auto-complete a sentence because what it's doing is probabilistically suggesting the next word that's logical in the sentence given its context. So, the teacher something, the teacher teaches is one possible outcome there. And then if you put the two sides together, the encoder and decoder, into an encoder decoder, this is known as sequence to sequence. It was developed primarily for machine translation of natural languages. So when you go to Google Translate, that's what you're seeing. You're seeing an encoder decoder turn English into German or German into Japanese or what have you. So in this case, you're filling in the appropriate words as you go through the whole system. Now, if we look at those three components, the encoder, the decoder, and the two put together, those are going to have some natural uses. So if we just look at the encoder, decoder as a whole, machine translation, text summarization, image captioning, and that's exactly what we've seen come out of Google over the past 5, 6, 7, 8 years, right? We've seen them begin to separate cat photos from non-cat photos. We've seen them put up translate.google.com, and we've seen that system improve and improve and improve. We've seen auto image capturing showing up in their search results. And of course, recently, we've seen a lot of text summarization activities along the way. If you just look at the encoder side, and as a reminder, that's the auto encoding portion. Well, we can use that as well, because this is learning a compressed data set representation from the input. So you're basically trying to find out what the important bits are. Well, if you're just looking for the important bits, you're really summarizing. And you can use that summarization for sentiment analysis, noise reduction in big data sets. You can use it for image comparison as examples. Now, the decoder side is what gives us the chatbot capability, because it's generating the next most probable word in these long sequences. So it's looking at that whole big stream of input in one go. It's passing it through these neural networks that are all trained up on all of language, based on all the stuff that it's read off the data sets it was trained with. And so you're putting it through this process where it's trying to figure out what's the next most probable word. Now, it's not just the most probable word, because then it would repeat a lot, right? And you want it to be able to be a little freeform. Peter and I were talking before this talk about sometimes you can even give an LLM the same prompt multiple times, and it'll produce different outputs. Now, why is that? It's happening because that softmax function at the end is variable. It's an algorithm. And that algorithm can have different properties, different preferences, depending on the scenario that system's being used for. A lot of what happens in the softmax is, sometimes you will say things like, don't just give me the most probable word every time, but you have a probability of a vector of 10 words or 5 words. And then you're running a little algorithm over that to decide which one you're going to select next. And that's where a lot of that variability comes from, is that function. So if you're just using the decoder side, this is where ChatGPT is just a decoder. It takes this time series input. It assumes that the output is a function, complicated algorithm, but a function of its past values. That's why if you feed it all the poetry in Lithuanian, it can write you a Lithuanian poem, right? It can talk to you and it'll sound pretty human, because it kind of knows the patterns. It's learned the patterns. It's embedded the patterns. So text generation is what a decoder does, and it's used to predict likelihood in any time series data. So one of the things, we talked about images on the left, but video, because a video is naturally a time series, is often a decoder function. So these things have been developed now for a good 5 years. They actually go a little bit farther back than that. But here, the ones that are highlighted are the ones that are publicly available. There've always been a lot that aren't. This is based on a late last year survey of them. Since then, we've seen some newer ones come out. Of course, Llama 3 came out just recently, for example, and of course, we expect GPT-5 to drop this month. Just in ChatGPT alone, there's been a tremendous amount of innovation. The dark arrows here, the full lines, indicate a direct evolution between versions, and the dashed lines indicate informed engineering iteration without necessarily a direct versioning. And you can see here that ChatGPT 4 has been out for closing on a year and a half, and 5 is supposed to be out in August. Don't know if it's going to happen yet. Don't know if it's going to slip. And we might note that with all the newer ones that are coming out, we see a few things happening. The anticipation, if you read your AI news in the popular press, the anticipation is that the step function, the big change in capability, is just going to keep going at that rate. AI is going to become sentient any moment now. It's going to become conscious. It's going to be a threat to humanity, et cetera. In reality, these things tend to progress in fits and starts. And we've had our big recent step function just a couple of years ago, and we're probably going to not get another one here for a while. We're in a period of consolidation and in integration and in a bit of engineering. One of the big reasons that that's true in large language models is because the assumption until just a few years ago was that the larger the large language model, the better. So, back on this slide, these are just large language models that are more than 10 billion parameters in size. So they're big, right? Some of these things are really big, hundreds of billions of parameters. So the assumption all through this period of the last 5 years was that if you build them bigger, you will get better results. Now, that really hasn't entirely turned out to be true. OpenAI put out an academic paper 4 years ago now, in 2020, noting that there were actually optimizations to be had. So depending on how much money you had to spend on compute and how much time you have to do the training, you could find yourself in a bit of an economic optimization. And you don't want to break out of that economic optimization, because one of the parameters of that trilemma is not just time and compute, but the other one's parameters. And so you could find that, your large language model, for the amount of compute you can afford and the amount of time you can give it, it is not going to get better by adding more parameters. And so this is what we saw with Llama 3. So Llama 3 is roughly 5 times bigger than ChatGPT 4. And yet it performs on par. Now, this was not a shock to AI researchers because we knew it violated the theoretic optimization models. But it was seemingly a surprise to Meta. So why is it that Llama 3 is not drastically outperforming ChatGPT? Partially the reason, I think, is because their data is so repetitive. They've got, data from all of Facebook and Instagram and all that sort of thing. But what they have is a lot of repetitive interactions between people that do kind of the same thing over and over. And just because you have a model with more parameters doesn't mean that the language has gotten bigger. The number of words used hasn't gotten bigger. So as they throw the similar kind of content at it, in bulk, what you get is the weights in those neural networks aren't changing very much. And so there doesn't turn out to be much value in having models that are bigger and more expensive to run because they don't do a better job. So a practical result of that is because OpenAI came up with this set of optimizations first. That's why you see both ChatGPT 4, which is the larger model, and then you see ChatGPT 4.0, not 4.0, 4.0, but 4.0 for whatever O stands for, optimal or something. And what that is a smaller model that's cheaper for them to run, but it still does a really good job with textual generation. So then you end up with this sort of life cycle, and this is credit to deeplearning.ai here. But I wanted to throw this up because there are a couple of misconceptions that are quite common in how you interact with an LLM. You'll note in the middle column, the adapt and aligning model. Once you've chosen the model, which you need to do now, and there are so many models to choose from, don't neglect that step. Don't just go to ChatGPT because everybody knows it. I recently had a problem where it turned out that the best one for me to use was Claude from Anthropic. And I had to try a bunch of them to figure out that was true. So choosing your model is important. Now, when you go and adapt and align your model, what most people do is they change their prompt until they get better and better answers. And sometimes they get frustrated when they can't create a prompt which is going to give them what they want. This is the bit that's known as prompt engineering. You just use the knowledge that you have to make better and better prompts. But there's a lot of other techniques in there, fine tuning and reinforcement learning with human feedback, et cetera. But those other techniques, other than prompt engineering, actually require you to work at the API level and retrain weights or train weights on a network that fronts the LLM, et cetera. And it gets technical. And so that's why most people are stuck at the prompt engineering side. But if you find you're not making progress in prompt engineering alone, maybe go back to choose a different model, because you'll find that different models are better at different tasks. Now, something that's come up a lot in the last year is the combination of LLMs with other forms of information retrieval systems, databases, graphs, knowledge bases of one form or another, big textual content systems, Wolfram Alpha, your company's payroll system or HR system, all the other kinds of data retrieval systems that we've created over the years. In that bucket would include all your other forms of AI. So here's an example of orchestrating LLMs with other systems. I'm going to give you two different examples. This example is where you ask an orchestration system to go look up a bunch of proprietary content or content in some kind of traditional information retrieval system. And the orchestration system uses that knowledge combines that knowledge with the human input to create a better prompt into an LLM. Right? So you're using these other traditional systems to create a better prompt for an LLM so that you get a better answer out of the LLM. That's one way to go. You can turn this process entirely on its head. You can orchestrate a system where a user asks a question, and then you get an LLM to create a prompt for you into some information retrieval system. Now, you can combine these in infinite variation, right? So you could create a system where you're querying a SQL database for some, company information. You're using that to prompt an LLM, you get the answer, right? And then once you get the answer, that answer might be structured in such a way that it provides a prompt into a graph database or into some other kind of system. And you can chain these together and you can feed them back on themselves. And a lot of the interesting work that's going on right now is in orchestrating LLMs into mixes with other information retrieval systems. Okay, so that's a high-level overview of the last couple of years of major AI research. What does this have to do with Web3? So with Web3, we looked at about 70 academic papers that have been published on the integration of Web3 and AI over the last several years. And as you can imagine, there isn't much material from 5 years ago, although there's some. A lot of people doing ML work 5 years ago with Web3. And the papers get more 4 years ago, more 3 years ago, more 2 years ago, more last year. Just an explosion this year. So when we look at the number of papers that are published in different areas, most of the papers have to do with either compliance and ethics, which is all the argument around transparent AI and hallucinations, how we deal with those contextually, et cetera. And there's a big cluster of stuff around economics and ownership. A lot of people talk about how we own our data that is used to train it. Are integrated into some kind of economic model so we can afford to pay for these AIs with Web3. And then there are all these other things off on the side. Up at the top, you'll notice the second one down in black, where it says Singleton Web3 and AI. That was Vitalik's term, Vitalik Buterin. And Vitalik talks in a very interesting blog post about the possibility of actually using an integration of AI and blockchains into a single system where the AI actually runs the chain at deep levels. And we'll talk a little bit more about that in a bit, because that's a fascinating concept, but there be dragons. One of the ones that's reasonably close to actually having borne some fruit is AI assisted software auditing. So we see a lot of AI assisted software development tools now. GitHub Copilot is a well used one. There are a bunch coming out every week. There's a new IDE that integrates AI in some novel way to help people code better. So it's not just code generation, but it's active code development assistance. Well, we see the same thing in software auditing. So we already have smart contract code generation in Solidity and other languages. We have some auditing tools that exist. You can feed Solidity up to Solidity source code up to several LLMs and ask it to analyze that code. But we have some issues here, and some of the issues we see in research is that perhaps the amount of Solidity in the wild is so small and the operations are relatively repetitive. And so we get some of these, when you take too much repetitive information, you train up any kind of AI system on it, they often get overtrained. They overfit to the curve of the input, and we might be seeing that with Solidity. There just isn't enough Solidity in the world to really train on a Turing complete system and be sure that it has developed a good understanding of what can be done in the language. So I think we have some real issues with that. We see it in code generation too. If you ask ChatGPT or some other LLM to generate a Python script that does bubble sort, it'll pop it right out. But if you ask it to solve some novel business problem it's never seen before, chances are good you're going to be doing a lot of iteration, and you're going to be spending as much time trying to understand what it's done as getting help from it having gotten you started. And part of that is because the inputs have been relatively small from the training data. Relatively small. I mean, they're still huge. There's a lot of open source code in the world, but not necessarily enough to train these things to solve really novel problems consistently. So we suspect there's going to be some slowdown in the progress in these for those reasons. Now, back to singleton Web3 and AI. This is actually, can we actually make blockchains where AI is, core to the operation of the network itself? There's some interesting papers on this, interesting research coming out. Generative fusion models, which were originally formulated for machine vision. There's some interesting work that was done here by Nguyen et al. Talking about how you can develop ConsenSys systems at low levels of blockchains, and to get these things to converge faster and improve the throughput and latency of blockchains. There's been some interesting work on both increasing the security and optimizing efficiency, and the sort of focus on those two general categories of the kind of work. But Vitalik in his blog post has specifically warned against rushing this. And I'm going to read out his quote for those who might be listening to this without seeing the screen. These applications have promise, but there are also many ways in which the underlying assumptions could fail. Hence, it is worth treading carefully, especially when deploying these applications in high value and high risk contexts. So I think that's a reasonable warning. It came out this year. We if we have systems that we built that we don't fundamentally understand how they're operating, and we're trusting people's fortunes to it, their money manipulation, that's a concern. I know that our industry is quite used to somebody losing $1 billion every Tuesday, but that doesn't mean it's a good idea. So what's been done to date? We have some code generation, we have some program analysis, we have some auditing tools. Those are good, they're improving, they're going to get better. Transaction anomaly detection on blockchains, where we have various kinds of deep learning networks and machine learning algorithms looking for anomalies and transaction flows. That research is showing some progress. There's some good early algorithmic trading stuff. I think we have a long way to go to catch up to TradFi algorithmic trading systems, but they're being implemented often with the help of AI, and all kinds of data analysis, heaps of data analysis. So that's kind of what we have today. So what's coming? I kind of put together this little matrix here. At the bottom are developers. Right now, we see a lot of coding assistants, program analysis, chatbots, in every single system. We're going to continue to see improvements in those. Down at the node level, operations that occur at a blockchain node, we're seeing some early work in transaction anomaly detection that might lead to some compliance specifications and EIPs and other kind of enhancements that rely on that transaction anomaly detection. If we get a singleton Web3 AI integration in some future chain or some version of some future chain, it's probably going to happen at that L1 level, although we might see it deployed at the L2 level first, right? And because it's cheaper to do. So we'll probably see some L2s pop out with that functionality first, and we'll be able to evaluate it before we build it into the core of the L1s. Algorithmic trading is happening now at the smart contract level and some of the L2s. I don't know what we're going to see that turn into. In the short run, I guess it's going to just follow the same growth path of maturation that happened in traditional finance. Beyond that, I can't guess. I'm not that kind of quant. And at the user level, users of Web3 systems aren't seeing this much at the wallet end or at the application end, but we hear talk about AI usage assistance, better trading, assistance in doing things. So, that might look something like this, where you might say to your wallet, hey, I'd like to transfer 5,000 USD worth of Sol to Ethereum on mainnet, and then use it to buy whatever the newest meme coin is you can find. And the system might come back with, all right, here's what we're going to do. We're going to find the current price of Sol in USD. We're going to transfer 5,000 USD worth of Sol to Ethereum. We're going to buy that amount of ETH. We're going to use that amount of ETH to buy PooCoin here, the new meme coin it found, and pay the gas. And then we're going to tell you how many PooCoins you now have. And so what we're doing here is we're kind of sketching out what that kind of AI assistant at the wallet level would look like. You're asking it to do something, and it's presenting an execution plan back to you. And you have to approve that execution plan before it proceeds. Now, remember, this is a probabilistic system, and it makes mistakes, and it hallucinates, and it does stuff that's complicated software on top of complicated software on top of complicated software all the way down. So if I were you in 2024, 2025, I'd be extremely careful about what you type here. I wouldn't personally be ready to trust real money to that kind of system. Not yet. Maybe it's going to come, but I don't think we're ready to jump into this kind of user interaction, even though technically we could build it. I wouldn't trust it yet. So in general, when we look at the Web3 AI integration, I think we've got, these kind of two directions. Just forgetting about the singularity here for the moment of complete combination. In the short term, what we have is Web3 helping AI and AI helping Web3. So Web3 helping AI, Web3 world can help AI systems with ownership registration, transparency, and who owns the data sets, who gets credit for the data, where the data came from, and then all the economics stuff. How do you pay for your AI systems? Well, we've got that nailed. We can handle your currency payment issues, your transfers, all those kind of economic operations. Now, AI helping Web3, there's a lot of work being done in optimizing security of blockchains with real-time running analysis of transaction flows on blockchains, and that work is being done with AI of one form or another. All kinds of efficiencies and some really interesting work on whether or not we can come up with new consensus algorithms based on some of the larger pool of AI concepts. You just imagine an orchestrated system where the orchestration system is talking to oracles and the blockchains are actually chatting to each other over peer-to-peer, having a conversation about whether transactions are safe and ready to proceed and how they should be ordered in a block and how they should be moved through the chain. We're not there, but I think that's coming. So, question for the audience. I'm really, really curious to see what all of you think about this. Do you think we're going to see singleton Web3 AI integration in the foreseeable future? And what do you think that's going to look like first? I threw out some ideas, but I'm really curious to hear some Q&A on this. Let's have a little discussion if we can, Peter, about this.
Sure. So I'm not going to throw my hat into the ring to start off with, but I'm sure someone else will. Does anyone have any thoughts, any ideas?
Come on, someone be keen.
Someone dropped off the call.
I've scared them all away.
Run for the hills.
Adrian, you've always got an opinion. What's your opinion, Adrian?
I don't look. I'll be honest with you. I don't know enough about Singleton to enter into this discussion. I'm really here to learn. I thought it was a fascinating discussion. What you opened up with, really, really good. But if you give me a couple of days, I will provide you with something. But at this point in time, I really don't know enough about Singleton and integration with the Web3.ai. So I'm very sorry.
No, that's quite all right. Look, that's a very thoughtful answer, and I appreciate it, and I appreciate your kind words. We'd love to see a comment either on the Ethereum Engineering Group meetup site or on the YouTube recording. So we'd love to hear your thoughts in a couple of days.
Okay, well then that'll be my task for you. I'll send it to Peter and to everyone else. From what you were discussing, it looks really interesting. But as I say, I just don't know enough about Singleton to make any real contribution. But hopefully in a couple of days, I will be able to.
I see Senator Johnson has joined us. Senator's been my partner in crime and in coming up this particular learning curve. Senator, you've read, I think, all of these academic papers that have informed this talk. What are your thoughts about eventual Singleton Web3 AI integration at this point?
I mean, I think it's a really interesting concept to have a single decentralized trusted AI. that an application can rely on. I think it's coming up with what would a purpose be that is where you can feel that you can allow some autonomy, but I think it's that whole sort of interplay between how much do we sign off to an AI and how much do we also, are we able to still maintain some influence and interaction on that. So I think to reach that stage, for some things that are not super sensitive, I can't see why that can't be done. But for other type of applications, I think it might be a mixture, like maybe not a complete sort of singleton type concept. Yeah, those are just my thoughts. I'd be really excited to see what's happening on that front, though.
Yeah, no, it's fascinating stuff. Thank you. Peter, are you ready to throw your hat in the ring?
Yeah, I've got a few different ideas. Some of you know that David, myself, and others did a paper and ideas on two-factor authentication for satellite control. So essentially, Earth stations controlling satellites are subject to being hacked. And wouldn't it be good to have a 2FA methodology? And actually, we could potentially do it via blockchain. And so you could imagine that you could have I don't know, going feeding into that a smart system of some sort, what do they call it? Like a knowledge system, knowledge base that can say, well, David's logging in as David, but when I've checked the calendar, he's on holidays. And so bringing in multiple off-chain things to essentially, and it could be monitoring for an event saying David's wanting to log in and deorbit the spacecraft. And so then it could, use some knowledge. But that's not like the generative AI sort of stuff. That's more knowledge systems, so more old school. So that's one that I can see that, that's an integration with actually spacecraft, Web3, blockchains, and AI. But I can see that you could have security. So that was a security one in itself, but you could imagine you could have security stuff where the LLM sort of thing is learning from the behavior on chain and what is normal, what's not normal, and could also be understanding what is happening in the world and know, look, the share markets have crashed. And these the crypto markets are currently correlated for these tokens with the share market, and hence this behavior on chain is expected, but this part here is anomalous. So trying to work out anomaly detection, and then maybe feeding that back. But so I don't know, is this singleton sort of stuff, or am I off mark on what singleton means?
Well, singleton in this sense is like, integrating AI techniques into the core of a blockchain for the blockchain operations itself. So to me, I suspect that when you say AI in that context, it's to be an orchestrated system. Right?
Yeah.
I don't think it's just going to be an LLM. In the orchestration world, people talk about LLMs being the so-called reasoning engine, by which they mean the thing that talks and interacts like a human, but its hard data comes from elsewhere, just like our hard data when we make decisions about what to do with the state of the world, come from different systems, might come from a database or what have you. Now, I think it's interesting. My suspicion is that we're going to see this play out kind of like DAOs did. In 2017, we had the DAO, the first DAO, and it seemed like a great idea, but its implementation was flawed and it fell down in a heap pretty quickly. And it was embarrassing, and people were scared of DAOs, and people lost money on the DAO. And yet, in 2024, 7 years later, we still have DAOs because people kept working on them, and we've had governance failures on DAOs. Well, we've come in the interim to figure out kind of why DAOs are failing in governance. And so now we're seeing DAOs with various mitigations against governance failures. And so what we might see is some kind of Web3 AI singleton that's developed as an L2, and it fails. And then eventually it's iterated toward success. And then maybe it has some kind of governance issues because the AI can't keep up with the complexities of the real world. And people will keep at it, and eventually they'll do better. And it might take us a decade or two, but we'll probably eventually migrate that down to the core operations of some L1 somewhere. So I would imagine it'll play out quite incrementally like that, but I don't, of course, know.
Yes. Yeah, I think incrementally sounds right. And so Sandra put a quote there about Vitalik's use of the term singleton, meaning it sounds like more a decentralized AI. And so I think the idea of, so that'd be like an open source. I mean, we can't say that open source decentralized stuff doesn't work because we got Wikipedia and we all benefit from it. But then,
yeah, but if you ask somebody on the Wikipedia editorial team, they might say it's not as easy as it appears.
Oh, I'm sure. I don't doubt that. But and I don't know, would we then be putting ChatGPT into the bucket of Encyclopedia Britannica that at some point will fall over because everyone's happy enough just to use the freebie version and not pay for the paid version? I guess that would be, that'd be the challenge to be able to create some open source decentralized version. And also you've got to have the actual economics of it has to work as well. Is it going to be cheaper to run a decentralized AI than a centralized AI?
Never. That's often the re-centralization of distributed systems, much less decentralized systems, is you're always going to get efficiencies by re-centralizing, which is why distributed systems like the web or decentralized systems like blockchains tend to have very particular use cases that are outside of the efficiencies of the more centralized systems. I mean, one of the brilliant things about the L2 layer is that we can get the benefits of centralization in those use cases where we want, and then still pin stuff back to mainnet.
Yes. Yeah. All right. So David and I have had a great chat, and Adrian and Sandra threw in some things too. But are there any other thoughts on the Web3 AI singleton?
Well, throw your comments out to Meetup or YouTube, and we look forward to talking more about it when you do. Thanks to everybody. Peter, over to you for merch and schedule. Thank you all for being a great audience.
Thank you, David. Very good.
Yeah, I was going to say thank you, David. We've all learned a lot. And yeah, I mean, I think the idea of coming up with a rationale and a driver for a decentralized AI would be actually great. Anyway, yeah, all very interesting. So the merch store is open. Yep, next slide, please. And yeah, we've got 3 talks coming up. So in 2 weeks' time, I'm going to give a talk on using Forge scripting, which is one of the tools from Foundry. And so that's about executing transactions and being able to script it all up. So it's actually a really great tool. We've got a pseudo anonymous person who's done a deep dive into the WazirX hack, and they're going to explain exactly what happened. And then 2 weeks after that, we've got James Finlayson from Immutable, who's going to talk about how you design a game economy. And so I mean, on Immutable, we've got 300 games signed up at the moment that are coming onto the platform and in the middle of, building their games, of which, I don't know, probably several dozen have already released. And I dare say this whole category of Web3 game is going to become, one of the big categories of games globally over the next, say, 5 years. And so I think it's actually a really interesting one to try and understand how do you design, something so that it makes sense. And it's actually a really super complicated topic. So anyway, it should be very interesting. Next slide, please.
I think that's, oh, there is one more.
Yeah, there is one more. And so if you're here today, there is a YouTube channel where the recording will be. If you're watching this on YouTube, then go to the Slack invitation. Oh no, go to Meetup, and there is a Slack work group or workspace, should I say, where you can fire your questions and ask stuff. And yeah, that is all. But before we leave, we've got David on the line right now. He's got AI front of mind and Web3. Are there any further questions for David? Nope. All right. I think we're all good. So thank you again, David. Great talk, and see everyone again in 2 weeks' time. Bye-bye.
Thank you, everyone.